Hi, my name is Mike Lawrence. This video is one of a set which is intended to provide a different interpretation of the experimental results that constitute the foundation of current physics. It is clear that the present explanation for what we see in the universe is good in many ways, but it is missing an overall coherence. My view is that we need to look at physics with new eyes and consider an interpretation that explains most things well, even if it does question just about everything. I do not disagree with any experimental results, only the interpretation of those results. And I do not say that the hypothesis that I'll be talking about in these videos is the theory of everything, and that everything I suggest is correct, but it is a start. Each video in the set will cover an aspect of physics. The whole set needs to be understood together in combination, because many aspects rely on each other, and any one taken on its own may not be convincing to those relying on the current interpretations, some of whom may actually be offended by the hypothesis. There will be links in the videos to other videos in the set that cover closely related or overlapping aspects. Within the boxes in the videos are representations of the motions of the particles and their composites, which I will be explaining more fully. I'm happy to answer questions where I can, perhaps providing links to where a deeper mathematical analysis shows why I say what I do, since equations and graphs do not make good videos, and will post replies where appropriate on Twitter. I hope you enjoy the videos and they enable you to better appreciate the absolute symmetry and simplicity of nature. But please remember, I'm not an experienced presenter, and although I state everything as if it were correct, this is only a hypothesis. This is video 16, why fermion masses are proportional to their charges. This is only a hypothesis, but because the neutrino has no mass, or at least a very small mass effect, and yet is linked strongly with the actions of the electron loop, then the only external difference between the two is the charge on them. The expectation is that the neutrino loop has the same frequency as the electron loop, but the muon twists are such that the total twist generated charges sum to zero. The same frequency link is expected for the muon-neutrino to the muon and the tau-neutrino to the tau, and each family can convert to another family by gaining or losing frequency, because all neutrinos are the same meons at different loop size. The neutrinos can change between families by gaining or losing frequency to other loops. However, unlike the totally symmetric meon twist positions within the electron loop, the neutrino loop has both symmetric and asymmetric versions. The symmetric neutrino loop has all the positive 1/6 meon charges orientated one way and the negative meon twist charges the other, with symmetric threefold symmetry. The asymmetric neutrino loop versions have either twofold symmetry or no symmetry, and these cannot be held within stacks that are based on threefold asymmetric quark loops. Neutrinos can be converted theoretically into antineutrinos by swapping all properties. A symmetric neutrino and an antineutrino are different only by 60 degrees of rotation, so it will be very difficult to tell them apart. The possible explanation for the appearance of a small mass for the neutrinos is that when observing them, there is a mixture of both symmetric and asymmetric ones, and the latter are causing the effect on the background merged pairs, which would otherwise not occur on the symmetric versions. The background is what causes the basic appearance of mass for loops, in that the rotating meons in the loops all have chains of merged pairs, part of the background, attached to them, dragging at the background and extending outwards for some distance from the loop. The greater the density of the local background, the longer the chains, the more the drag chains affect the loop, and the faster rotating of the loop, the greater the loop frequency and its motional energy, then the more the background is affected by the loop. The result is both frame dragging and effective warping of the equivalent of space-time. The amount of charge on the loop will strengthen the effect of the dragging change, which transmit the effect to the background charge fields. The lower the loop charge, the lower the dragging effect. So the charges on the loops probably directly affect the observable amount of the loop frequency, its mass, which we observe. One issue that could help in uncovering the loop charge to loop frequency or mass relationship is the change in properties between photons and mesons when breaking and reforming loops. Although this has been explained elsewhere in terms of the strong fields generated by massive black holes breaking loops into chains, each meon itself has a far stronger mass and charge field than any massive black hole. This means that ripping loops apart can happen anywhere, where there are meons and loops. That means everywhere. So the change of identity of two loops can occur almost anywhere, where one or more meons or meon pairs in each loop is swapped. Two swapped meons do not have to be from the same meon pair that was unmerged together originally from within a zero-mass black hole. A simple example would be a photon. As an electron-positron loop, each swapping a meon pair to become a down quark and an anti-down quark. The charge, spin and rotational rates would be unchanged if the two loops started out merged as a photon and ended as a photon. This is unlikely, as the asymmetry of the quarks preclude them from forming photons, and instead the two asymmetric loops become a pion, in this example fast-moving with total spin 1. Since there are no other loops involved, other than needed to provide the strong mass and charge fields, the total mass energy and other properties should be conserved at meon level. That what is observed at loop level may be very mixed, with the pion mass for the same loop frequency being 1/3 of the electron and positron masses. A close relationship of this transformation may shed more light on this change and charge to observable mass relationship. Related videos will be 25, loop symmetries and stack formation, and 26, how do loops and the background interact. Thank you for watching.